Example 4. What mass of silver would be liberated from a solution by the same quantity of electricity that liberated 0.32 gram of copper? Solution. Equation of reaction. 1. Silver of having one positive valency will absorb one electron to form neutral silver. Equation of reaction 2. Copper having two positive electrons will absorb two electrons to form neutral copper. From equation 2, 1 mole or 63.5 gram of copper is liberated by 2 moles of electrons. 0.32 gram of copper is liberated by 2 over 63.5 times 0.32 over 1 mole of electrons. From equation 1, 1 mole of electron liberates 1 mole or 108 gram of silver. Therefore, 2 over 63.5 times 0.32 over 1 mole liberates 108 over 1 times 2 over 63.5 times 0.32 over 1 gram of silver, which will give us 1.08 gram of silver. Example 5. Calculate the current that will deposit 0.16 gram of copper in 1 minute for copper 2 tetraoxosulfate 6 solution. Solution. Equation of the reaction. Copper having two positive valency will absorb 2 electrons to form copper neutral. From the equation, 63.5 gram of copper needs 2 moles of electron or 2 times 96,500 coulombs. Therefore, 0.16 gram of copper needs 2 times 96,500 over 63.5 times 0.16 over 1 coulombs, which will now give us 486.3 coulombs. Coulombs equal to current in amps times time in seconds. Substituting time, we have 15 times 60 to convert it to seconds, and coulombs is 486.3. We now get 486.3 is equal to current times 15 times 60, making the current the subject of the formula. Therefore, current will now be 486.3 divided by 15 times 60, which will give us 0.54 amps. Example 6. Calculate the volume of oxygen liberated in the anode at the same time as 3.2 gram of copper is liberated on the cathode by the electrolysis of copper 2 tetraoxosulfate 6 using platinum electrodes. Solution. Reaction at cathode. Copper having 2 positive electrons will absorb 2 electrons to form copper. Reaction at the anode. 4 hydroxide ion having 1 valency, negative valency, will now form 2 moles of water, 1 mole of oxygen, and liberate 4 electrons. From the equation above, 1 mole of copper is liberated by 2 moles of electrons, and 1 mole of oxygen is liberated by 4 moles of electrons. Therefore, 4 moles of electrons will liberate 2 moles of copper. That is, 2 moles of copper will be liberated at the same time as 1 mole of oxygen. But 1 mole of copper is equal to 63.5 gram, and 1 mole of oxygen is equal to 32 gram or 22.4 dm cube at STP. Therefore, 2 times 63.5 gram of copper is equals to 22.4 dm cube of oxygen, and 3.2 gram of copper is equals to 3.2 times 22.4 divided by 2 times 63.5 dm cube, which is now giving us 0.56 dm cube, or equals to 560 cm cube. Example 7. How many grams of chlorine can be produced by electrolysis of molten sodium chloride at a current of 10 ampere for 5 minutes? Given Faraday constant equals to 96,500 coulombs, and molar mass of chlorine equals to 35.5. Solution: coulombs of electricity equals to current times time. On substitution, coulombs equals to 10 times 5 times 60 equals to 3000 coulombs. 96,500 coulombs of electricity equals to 1 Faraday. Therefore, 3000 coulombs of electricity equals to 3000 over 96,500, will give us 0.0311 Faraday. The half cell reaction is equals to 2 moles of chlorine having 1 negative valency will now give 1 mole of neutral chlorine plus and liberates 2 electrons. 1 mole or 2 moles of electrons. From the above equation, 2 Faraday produce 1 mole of chlorine. Therefore, 0.0311 Faraday produce 0.0311 over 1 times 1, which will give us 0.0156 mole of chlorine. 1 mole of chlorine weighs 71.0 gram. Therefore, 0.0156 mole of chlorine will weigh 0.0156 over 1 times 71, which will give us 1.11 gram. Therefore, number of gram of chlorine produced is equal to 1.11 grams. Example 8. In electrolysis, metal cation M having 3 positive valence is liberated at the cathode. Calculate the mass of M deposited when a current of 2 amp is passed for 30 minutes. Relative molar mass of M is equal to 53. 1 Faraday constant is equal to 96,500 coulombs.